So in the last video, we talked about the derivative of tan x. Now we're going to talk about the derivative of secant x. We're basically going to follow the same idea. Secant is 1 over cosine x. And pulling again from our memory, we have those two derivative rules for sine and cosine. Derivative of sine is cosine, derivative of cosine is negative sine. Now we don't need the derivative of sine rule here because our problem just has cosine in it. But once again, this is a quotient. That's the only way to think of this. 1 over cosine is a quotient. And we don't have any other option right now. Later on, when we get to something called the chain rule, we could write that 1 over cosine x as the quantity cosine x to the minus 1. And then we could use that chain rule idea to work the problem out. Although really, it's much better to approach this one here from the quotient rule. So we work that out. That's going to be the bottom function cosine times the derivative of the top. Well, the top is 1, so that's going to be cosine times 0 minus the top 1 times the derivative of cosine. Derivative of cosine is negative sine. And that'll all be over cosine squared. All over cosine squared. And then we can simplify. Cosine x times 0 is just going to be gone. A minus and a minus is going to make that positive sine x over cosine squared x. And that's a perfectly legitimate answer for the derivative of secant squared. It is sine x over cosine squared x. However, we traditionally write this answer a different way. And that's by taking the sine x over cosine squared x and kind of rewriting it. We take one of the cosine squareds and group that with the sine, so that we get sine x over cosine x. And we take the other cosine x in the bottom there and we group that with a 1, so we get times 1 over cosine x. And then sine x over cosine x is our tangent, and 1 over cosine is our secant. So tangent x, secant x, or alternatively, secant x, tangent x. You could write it either way. And so that's the derivative of secant. In that same set of notes, you have a turn-in problem where you're asked to derive the formula for the derivative of cosecant. And it's going to follow a very similar process.